Hello Algebra 1 students, here we are in Unit 7, Tier 1, Lesson 2b. Let's check off our booklet. Hey guys, here we are in Lesson 2b of Tier 1. We're going to start working on graphing quadratics when it's in vertex form. Okay, so like any other function that we've dealt with, there is a parent function of a quadratic, and this is the quadratic's parent function right here, and it's just y equals x squared. Okay, and then we will manipulate that as we move forward. So let's plug in some values here. Whenever you plug in values, you want to be simple, so let's go -2, -1, 0, 1, and 2, right? So if I plug in -2 for x into this right here, all that means is it's going to be -2 times -2, right? Well, -2 times -2 is 4. Similarly, if we plug -1 in, you're going to have -1 times -1, which is going to be just 1. And then if you plug 0 in, 0 squared is 0 times 0, which is just 0. If you plug 1 in, it's going to be 1 times 1, because 1 squared is 1 times 1, and that's just going to give us 1. And then if we plug 2 in up here, just like -2, it's going to be 2 squared is the same as 2 times 2, right? So 2 times 2 is 4. So now if we come over here and plot this, all right, we're going to have 0, 0, which is right here. We're going to have 1, 1, which is right here. And then we're going to have 2, 4, which is right here. So -1, +1, so it's left 1, up 1. And then -2, +4. Okay, and let's sketch this real quick. So this is my parent function of my quadratic, right? If you look, the vertex are the point that it changes direction is right here in the middle again, just like absolute value. The difference between this and absolute value is after the 1, 1, it grows bigger, right? Because it's getting squared, right? So just for fun, let's say if we put in 3, +3, well, what's 3 times 3 is 9. So our next one would be 3, and then it would be off the grid. It'd be up here at 9. So our vertex is 0, 0, in the parent function, right? Starts at the origin. And then there's this new thing we're going to introduce. It's called the axis of symmetry. And all that is if you look at this shape, it's the same on both sides of the vertex. So there's a line, right? Right here. This is the axis of symmetry. This is the point to where if we cut this thing in half, it would be the same shape on both sides. So if you come over here, we always state the axis of symmetry as the equation of a vertical line. And the equations of vertical lines are always equal x equal. Well, what's the value of x at this axis of symmetry? Well, it goes through the origin, so the value is 0. So our axis of symmetry on the parent function is x equals 0. All right, now let's come down here. So just like in the last lesson when I was trying to remind you, remember that the outside transformations are the k's right here are up and down, or vertical, however you want to say it. And then our inside transformations, which is right here with the h, these are left and right. And they are also horizontal. And remember, this is the most important part. They're opposite of what we think. So like if you had -6, you would think go left 6, but in reality you go right 6. So let's come down here and do one with some transformations. If I understand that h comma k is going to be my vertex, right? I know that this 3 is my h and this 1 is my k, so my vertex is definitely going to be 3, 1. The other way we could do this is we could say, well, the inside from the parent function tells me -3, so you would think left 3, but it's opposite. So I'm going to come over here and go right 3, 1, 2, 3. On the outside, it's up 1, right? So from the parent function, up 1. And now I'm going to erase this out. So now I have my vertex, and I just got to come up here to the parent function, right? And it goes over 1, up 1, over 2, up 4. So from here, I got to go over 1, up 1, over 1, up 1, and then over 2, right? 1, 2, and then up 4. 1, 2, 3, 4. And then over 2, 1, 2, and then 1, 2, 3, 4. So now I have successfully made a quadratic sketch. Doesn't have to be perfect, it's just a sketch of this quadratic equation in vertex form. That's why we like vertex form, because you can graph it really fast, right? Because it's just like graphing an absolute value, as long as you understand when you go over 2, you go up 4 instead of over 2, up 2. So our transformations here would be, we'd say we went right 3 and we went up 1. That's what our transformations would be. And we would say our axis of symmetry, that new thing that I introduced to you, which is the part that cuts this thing in half right here, we would say our axis of symmetry, it's also referred to as AOS a lot of times in mathematics, axis of symmetry. We would say that is x because it's going to be a vertical line. X equals, well, what's the x value right here? Well, it's 3. So our axis of symmetry would be 3. Good luck on your practice sets.